Okay, so you probably already read this prostate example, this prostate cancer one. And what I did is I underlined some important information. First of all, in red, called that group 1, men who had surgery. And group 2, underlined in green, those are men who did not have surgery. Okay? And I answered the first question in part A right here. I answered A. And I said, is it an experiment? Well, I asked myself, is there random assignment of treatments? And if you go up to the blue that I underlined up here, yes, it says randomly assigned. So this must be an experiment. And so when we go and check our conditions, we should do that right now. Let's check our conditions. And I'll just go a couple screens here away and check our conditions. So the conditions and assumptions are really simple here. Okay, we're going to check for independence. And we've got to check it on two fronts here by saying, and I'm going to say, well, men who get prostate cancer don't affect each other. In addition, we can see that the 10% condition is met. There's probably more than, if I go back to the there's 347 and 348. Whoops. So there's greater than 300,470 men who get prostate plus 3,480 men that get prostate cancer. So that's check. Okay. We have random assignment of treatments. We already talked about that earlier. So that also helps with my independence up here as well. So that person getting a treatment or not getting a treatment doesn't affect each other as well. And then success and failures. Okay? And so if we do our success and failures, we have to check both groups, so it's just a little bit more work. But it's easy to see that I have 16 and I have 31, which are both greater than or equal to 10. And then if you subtract it from 347, that this is the successes, the number of men who died, I guess, and the failures. It's kind of weird to define successes as death, but that's what we're doing here. If we do 347 minus 16, that's greater than or equal to 10, check. And 348 minus 31, that's greater than or equal to 10, so check there. So we met all our conditions. So that's good news. So I'm going to go back a screen, and remember that when you want to do a confidence interval, you center it around your data. So that's what I got here. I've centered it around the data. Okay? And this part here is my margin of error. Okay, that's my margin of error. The only difference is I need to, the hard part is this right here. This part right here. If I take that out there. That part, what do I do there? So I'm going to go a couple screens. I'm going to do this on the next screen over there. Okay? A couple screens back. So we remember the standard error for a proportion is the square root of p hat over q hat over n. But we're going to have to do the variance of it. And you're saying, why do the variance of p hat? Whoops. Well, remember when you have two random variables, variances add. So I'm going to have to, this is going to be p hat q hat over n. So now I'm just going to add two of them. They're going to be the exact same formula. The standard error, p1 hat minus p2 hat, even if we're subtracting, we still add variances, is going to be the giant square root of p1 hat q1 hat over n plus p2 hat q2 hat over n. So when we get that, we get the standard error. And we're going to go, and I'll just pause it here, and I'm going to find out what those numbers are. I'll write them in. Okay, so I've got those numbers there. I'm going to add them in a second here. And I get this number here, 3.59 times 10 to the negative 4. And if I take the square root of that, don't forget that will mess everything up if you don't. When I take the square root of that, I get 0.019. Okay, so I'm going to go back to the screen and go back and put our numbers in. Okay. I got to do some erasing here. I got some mistakes here from before. Okay, so our number was 0.019. I'm going to multiply it by 1.96 to get my margin of error as 0.037. I've got some more mistakes I'm going to erase right here. So if I subtract 0.037 from that, I get 0.0. Whoops. 0.0.
What are you doing? Huh?
So I got about negative 0.08% difference. In other words, I'll explain this confidence interval in a second here. And then I'm going to go the other way. Negative 0.043 plus 0.037. Negative 0.006. So what does this confidence interval mean? Okay. Well, remember we were building a 95% confidence interval if you look at the second bullet. So the 95, so we are in this case 95% confident the true difference in death rates is between 8% lower to, I'll go back here, to 0.6% lower for those who had surgery. Okay, so that's the interpretation of our confidence interval. We're 95% confident that the true decrease in death rate is between 8% and 0.6%. That's the decrease by having surgery. So let's look at the last question. I think we can answer it really quickly here. Okay, so I'm going to answer this. It says, based on your confidence interval, is there evidence that surgery may be effective in preventing death from prostate cancer? Well, we're 95% confident the truth is below 0. If there was no difference, then if there's no difference, then P1 hat minus P2 hat equals 0%. But we got a difference. Does our number fall within negative 0.08 and negative 0.006? That's the question. Well, we think no. No, it doesn't. So we are 95% confident that surgery improves survival. I don't have enough room, so I'm just going to put survival. That's how we answer that question there. We're not there. If there was no difference, they would be 0%, but 0 doesn't fall within our confidence interval. It doesn't fall in here. 0's not in here. So I'm confident, 95% confident that surgery improves survival.